In this video, we're going to begin our lecture on section 12.5, lines and planes in space. In particular, in this first video, we're going to cover lines. So first, a line in 3 dimensions is determined by some point, x0, y0, z0, in a line, and a vector, a, b, c, that is parallel to that line. This parallel vector, v, is called the direction vector. And then if we let x, y, and z be any point on the line, we can use what we call parametric equations as a way to write out this line. And that is given by x is equal to x0 plus at, y is equal to y0 plus bt, and z is equal to z0 plus ct. Again, x, y, and z will be any points on the line. x0, y0, z0 are a point on the line, is a point on the line that we already know. And then a, b, and c just come from a vector that is parallel to the line, or in other words, a vector that tells us the direction of the line. And then we let t be any real number, and that'll give us all of our points on the line. So for our first example, let's look at example 1. Find the parametric equations for a line that passes through the 2 points. A is -8, 1, 4, and B is 3, -2, 4. To do this, we need to find a vector that is parallel to a line that we're trying to determine, i.e. a vector that is along this line. So we can find the vector AB. That is given by 3 minus -8, comma, -2 minus 1, 4 minus 4. This is the vector 11, comma, -3, comma, 0. So 11, -3, 0. Sorry. There we go. And so that vector is, again, a direction vector for the line we're trying to find the parametric equations of. This gives us the parametric equations. X is equal to x0 plus at. Well, x0 is, we can just pick this first point up here. So x0 is -8. Plus at, a is 11, so this is 11t. Then y is equal to y0, which is 1, plus bt, which is -3t. And then z is equal to 4 plus 0t, or just 4. And so this is our parametric equations that define the line through the points A and B. Move on to example 2 now. So example 2 says to find parametric equations for the line 2, 1, 0, and perpendicular that goes through the points 2, 1, 0, and is perpendicular to both the vectors I plus j and the vector j plus k. Okay, so if we have 2 vectors, I plus j and j plus k, and we want to find a we want to find a line that is perpendicular to both of those vectors. Well, a vector that is perpendicular to both of those, if we recall, is the vector that is the cross product of those two. So let's take the cross product of 1, 1, 0, and 0, 1, 1. Okay, that is the determinant of this 3 by 3 matrix. So that determinant is the vector 1 minus 0, comma, -1 minus 0, comma, 1 minus 0. This gives us the vector 1, -1, 1. And that vector is perpendicular to both the vector ij and the vector j or sorry, I plus j, and the vector j plus k, which means it points in the direction of the line that we are trying to find. So our parametric equations are x is equal to x naught plus at. So this is 2 plus 1t. Y is y naught plus bt, which is 1 minus 1t. And then z is equal to 0 plus t. And this is our parametric equations for that line. And that ends our first video. We'll pick up the next one with a discussion on planes.